All right, today's lesson, it's about financial mathematics, and it's a past exam paper that was written in KZN in the year of 2024. Now, from this particular question paper, there were 4 key things that they wanted. Number 1, they focused on the period of savings to say that how much amount of time, so we need to calculate that. Then number 2, they wanted to know the depreciation using the reducing balance method. Number 3, they also wanted to find out the interest rate, considering that you had been given a scenario which used compound interest, and this interest rate, how to find the interest rate. And last but not least, you don't want to miss number 4. What were they focusing on? They wanted an accumulated amount when a withdrawal had been made during the investment period, right? So how to calculate that? And this particular question, I will show you 2 different methods to use, and then that way you can have options in an examination, from the 2 options, right? So let's get started. Now, on question 8.1, it read as follows. Ms. Kwala invested 30,000 rands at an interest rate of 12% per annum, simple interest. After N years, the accumulated value of her investment was 51,600. Calculate the value of N. So what are the key things that were given? Number 1, we're told to say that it's 30,000 rands. What is the initial investment? And we are told the interest method, which is simple interest, 12% per annum. And then in the future, right, we are now told that it was 51,600. That was the accumulated value. Now they want us to talk about how much time did she make this investment, or for how long was this investment, for the figure that was 30,000 to end up accumulating 21,600. So let's go. So now this is our formula when we're using simple interest. A is equals to P open bracket 1 plus IN close bracket. What does A stand for? It stands for the accumulated value, right? And then when we go to P, we are now talking about what? The principal, the amount which has been initially the amount which is initially invested. I stands for what? The interest rate. And then N stands for the what? The period, right? So from our scenario, we are told that the accumulated value is 51,600. So we now write 51,600 is equal to, we are told that the initial principal was 30,000 rand. That is the principal that was invested. And then open bracket 1 comes with the formula 1 plus I, the interest rate, we are told that it's 12% per annum, and it's simple interest. So we now say 0.12 multiplied by. Now this 0.12, I got it as a result of saying 12 over 100. If you got your calculator, then it will give you this decimal. But you have got an alternative whereby you can just go and write 12% like this, right? So you press your shift and then you press the opening the opening bracket on your calculator, then it gives you 12% like that. Then you multiply by N, the period is what we are calculating for. We do not know for how long did Ms. Kwala make this investment, for how long. So now this is the initial part. Now what do we do? Now 30,000 is multiplying by what is in the bracket. So what do we do next? We do the opposite, right? We are looking for N, which means that everything else which is not N, we need to remove it. So if this is multiplication, the opposite of multiplication is division. So we now divide by 30,000 and we divide by 30,000, right? So now we're left with 51,600 over 30,000, right? So we now write it as 51,600 over 30,000 now, which is equals to what? Now here we have got 1 plus 0.12. 0.12 multiplied by N, that is 0.12 N, right? So now this is a like term of that, so we transpose it. So now we've got 51,600 over 30,000. Then we subtract what? It was a positive, it's now a negative, which is equals to 0.12 n. Now we are looking for n. So what do I then do? I then go ahead and divide by 0.12 on both sides. So I come here and I divide by 0.12. 0.12 into 0.12, that gives us n. So I come here and I say, therefore, n is equal to, I go to my calculator. Now, I say that I've got 51,600 divided by 30,000 minus 1, which is equal to this figure. I turn it into a decimal number. Now I divide it by what? I divide the answer by 0.12, which is equals to 6, right? So this 6 which I got, it means that Miss Kwala, n is equals to what? 6 years. Remember, we're looking for time, the period or time. So it means that Miss Kwala invested their money for 6 years using the simple interest, and then after 6 years, she had this amount of 51,600, the accumulated value, right? And just like that, 2 marks. Let's go to the next question. All right, so number 8.2 states that the total number of bees in an apiary are declining each year at the rate of 2.5% of the total number of the previous year. There are currently 20,416 bees in the apiary. How many bees were in the apiary 8 years ago? So this particular scenario is simply telling us about what? People who get to keep bees. Normally we call it a beehive, but they've used the word apiary, right? Apiary here. Now, we are being told that these bees, right, they are declining, meaning to say that the numbers are becoming less and less and less. And we are given that they are declining at 2.5% per what? Per annum. Now, the first question that arises is that this is a case of what? This is a case of the fact that they are declining, and the decline means that depreciation, right? So we need to answer the question that which method are we going to use in terms of what? Calculating the depreciation. Because remember, we have got 2 different methods, right? Where we say A is equals to P open bracket 1 minus IN, or we've got an alternative, another one, a different method, which is P open bracket 1 minus I to the power N. Now, this one, which is on top, right? It tells us that the decline will be constant, meaning to say that if we are going to calculate and we find that, okay, they're declining at what? 500, it means that they're declining every year. 500 bees are what? Are being killed, right? Or are disappearing from the face of earth. However, we can't use this particular method because we can't be certain that a constant number of 500 is the rate at which the bees are what? Are declining. So therefore, we now use the what? The reducing balance method, right? Because it's unpredictable. The rate at which these bees are declining is unpredictable. We can't know for sure. So that's why we choose to use what? The reducing balance method. So let's take it. Let's go back to the question. So the total number of bees in an apiary are declining each year, right? And then at the rate of 2.5%. So here we come and we say that we've been given interest, which is 2.5%. And then of the total number of the previous year, there are currently 20,416. This A is the what? The present, right? So we say A is equals to 20,416, right? Now, how many bees were in the apiary 8 years ago? So N, which is the period, we say N is equals to 8 years. However, P, 8 years ago, the number of bees that were available 8 years ago, it's what is unknown. That's what we are looking for, right? So now that I filled out, I know what to do. I need to substitute. So now I say my A is 20,416, which is equal to P, unknown, open bracket 1 minus the rate of decline is 2.5%, which is now 0.025, close bracket to the power 8, right? When I've done this, now I'm looking for P. So which means that I come here and I divide there. I say open bracket 1 minus 0,025 close bracket to the power 8 and 1 minus 0,025 close bracket to the power 8. These two, they cancel, so therefore I can conclude that therefore P, I won't say is equal to, I will say that approximately, because like I said, we are not certain about the figure, right? So now I go and I say 20,426 divided by open bracket 1 minus 0,025 close bracket to the power 8, which is equal to, so there were approximately 25,011 Bs. Now we can't say comma something here, right? But since there is 8 here, we can add 1 here. Why are we not using these decimals? Because remember, they are Bs, right? So we can't say that there is a fraction of a B. So now we say approximately 25,012 Bs. That is the number of Bs that was available in an apiary 8 years ago, right? Now let's go to the next question, which is 8.3. So question 8.3 read as follows. Mrs. Howard invested 10,050 rands, okay, on 1 January 2020 in an account that paid interest at the rate of X% per annum, which means we must look for the percentage. And this X% per annum compounded quarterly, right? Meaning to say it compounded 4 times. Remember, a year has got to 12 months, and when we say quarterly, we say 12 divided by 4. So after every 3 months, it would compound. All right. The accumulated amount in that account on 1 January 2024 was 13,867. Calculate the value of X. All right. So let's go ahead and write our formula. All right. So I've written our formula, which is A is equals to P, open bracket 1 plus I, close bracket to the power N. Now, remember, A is the accumulated depreciation, and we are told that Mrs. Howard in the future, after 4 years actually, she got 13,867 rands. After she had initially invested 10,050 rand, which is P, our principal, and then the interest rate is what we are looking for, and we've been told that we must use the letter X, so we say X percentage is what we are looking for. And then N, remember it was from January 2020 to January 2024, so which means that it is 4 years, right? So now we were also told that it was accumulating on a quarterly basis. So this X% which we wrote, it's supposed actually to be written as X over 4 to accommodate the compounding period. So now I'm going to write my 13,000, the accumulated depreciation, accumulated amount, 13,867 is equal to, the principal is 10,050 rands, and I open the bracket, I say 1 plus, my interest is what I do not know, so I write X over 4 to accommodate the accumulating period. Now, as far as what N is concerned here, right, the years, what happens? This is what happens. 1 year, like I've said, the money compounds 4 times, right? But we are having 4 years. So if 1 year it's 4 times whereby it compounds, so it means year 1 4 times, year 2 4 times, year 3 4 times, year 4 4 times, and which is basically 4 times 4, right? And when you say 4 times 4, it is equals to what? 16. So here on N, we say to the power 16 because this money compounded 16 times, right? So let's proceed with our calculations. Now, here the 10,050 is multiplying by that. We do the opposite. The opposite of multiplication is division. So we divide by 10,050 on the right hand side, and we divide by 10,050 on the left hand side. Now these two, it means that they cancel out. So at this, on the next stage, we are now given 13,867 all over 10,050, which is equal to, now because we are no longer multiplying, okay, we now have got 1 plus x over 4 to the power 16. Now we want to get rid of this power 16, so we use the opposite, which is the 16th root. So we come here and we say the 16th root, right? 16th root. But remember what we have done on the right hand side, we must do on the left hand side. So we also say the 16th root here. Now the 16th root of this, it gives us what? It makes us lose this 16th power, which now makes us remain with what? Without the brackets. Now we've got 1 plus x over 4, right? And then we take this and we say that we've got the 16th root of what? 13,867 over 10,050. Like that. All right. So from there, what am I going to do? Because at this point in time, I just don't want to go to the calculator and just press. Now, I'm going to transpose this one. It was a positive, it becomes a negative. So now I write that I've got the 16th root of 13,867 divided by 10,050. And then what am I going to do? I'm going to subtract 1, which is equals to x over 4. Now at this stage, I can go ahead and use my calculator. It's fine, right? All right. So now I say that I've got the what? The 16th root of 13,867 divided by 10,050. Then I take out the, I say minus what? Minus 1 like this, which is now equal to, it gives me this long decimal number 0,020. So I now write that I've got 0,020, but since I've got a lot of decimals, I now use the ellipsis, these 3 dots. It tells the examiner that the decimals are continuing, so which is equals to x over 4. However, I do not want this denominator of 4, so I multiply by 4 this side and I multiply by 4 on the other side. Now these two, they cancel out. Now when I go, remember I still have got 0,020 on my calculator, so I must now multiply it by what? By 4. So here I come and then I multiply by 4, which now gives me 0,081. I put another ellipsis, which is equals to x. But remember, we're looking for this. This is the percentage, but it's in decimal form. We want it as a percentage. So we now must multiply by 100. So I come here and I multiply by 100. Now I come here and I say, therefore, x is equal to, I go to my calculator, I now say, I still have got the number here, the entire number. I multiply by what? I multiply by 100, which is now equal to what? 8,13. I was told to round off to 2 decimal places. So I now say 8,13 because the third decimal number is 0. So it doesn't change this one. So it becomes 8,13 percentage. And then just like that, I found my percentage. And this question carried 4 marks. So I will get 4 marks for every stage because I did not jump any particular stage. All right, let's go to the last question, which is 8.4. 8.4 is interesting for me because it has got alternative methods and it needs you to really apply your mind. Right. So how does it read? It reads as follows. Mr. Mungai invested 50,000 rands in a savings account for 7 years, right? Key, he invested 50,000 and we're given the period that it is for 7 years. The investment and interest at the rate of 14% per annum compounded monthly. Okay, so we know it's 14% and it's compounding on a monthly basis. All right, for the first 3 years. Okay, so out of the 7 years, it compounded at 14% per year per annum on a monthly basis for 3 years, which means that we are dealing with a changing periods. The rate of interest changed to 13% per annum compounded half yearly, right, for the remaining 4 years. Now, Mr. Mungai withdrew 6,032 rand from the account 5 years after making the initial deposit. Hallelujah. This is interesting. So we have got changing, interest rate periods. And not only do we have that, we have got a withdrawal. So let's see the first question. Now, 8.4.1 says, calculate the accumulated amount in the account 3 years after the initial deposit, 3 marks. So this one, it's easy. Piece of cake. Let's go ahead and and calculate. So this is the method which you're going to use the formula. A is equals to P open bracket 1 plus I, the interest rate, over the compounding period, close bracket, the period multiplied by the interest. So the compounding period, sorry. So the question is asking, after 3 years of making the initial deposit, how much? So the accumulated amount we do not know. This is the unknown. The principal that was initially deposited by Mr. Mungai is 50,000 rands. So we know that this is 50,000 rands. And then the interest rate for the first 3 years was 14%, right? So we are told that it's 14% and it compounded on a monthly basis. So it's 0.14 divided by 12. And we are told that it's for 3 years. So which means that here we say 3 years. So when I come and now say A is equal to the principal, which is 50,000 rands, and then I open the bracket, I say 1 plus I now put this 0.14 over 12, close bracket. Now, I know that it's for what? The period is 3 years, right? So I say 3 years multiplied by, right? It was compounding on a monthly basis, which is multiplied by 12. So 3 multiplied by 12 is equals to 36. So I say to the power 36 here, right? And then I say, therefore, A is approximately how much? Then I go to my calculator so that I can figure out how much Mr. Mungai had in his account after 3 years, right? And also bear in mind, Mr. Mungai did not withdraw the money after 3 years. The money remained in the account. So we now say 1 plus 0.14 divided by 12, close bracket, to the power 12. No, not to the power 12, to the power 36. Sorry for the minor error. So now, approximately, Mr. Mungai, we have 75,913.299. So we look at the third decimal, which is 9, which adds 1. So we say plus 1, that it becomes 9 plus 1, which is 10. So the 0 carries over, then it becomes 30. So 75,913.30 cents. 75,913 rands and 30 cents. That is what Mr. Mungai will approximately have after 3 years. 3 years in, right? All right. So let's go to the question which I enjoy, 8.4.2. The question which I enjoy is simply ask the question. Calculate the accumulated amount in the savings account at the end of the 7-year period, right? So we must know how much Mr. Mungai has got in his savings account after 7 years, right? After making the initial deposit of 50,000 rands. So here in this particular case, we need to now deal with the timeline. So here on this space, here on the side, we are going to deal with the timeline. I need to draw up the timeline, and then from there we proceed to have what? We proceed to do the calculations. Without the timeline, we may make some mistakes. So let's go back. We are told Mr. Mungai invested 50,000 rands in a savings account for 7 years. The investment earned interest at the rate of 14% per annum compounded monthly for the first 3 years. So when we come to our timeline, we now say that T0, this is the beginning of the investment, and then we come here, we say we've got T3. So at the beginning of the investment, Mr. Mungai deposited 50,000 rands, and we are told that for the first 3 years, from T0 to T3 here, the amount was accumulating at 14% per annum, which is 0.14, and it compounded on a monthly basis, which is divided by 12, right? So this is the first one. The first one, part of our timeline. Let's continue with the scenario that was given. Then the rate of interest changed to 13% per annum, compounded half yearly for the remaining 4 years, meaning to say that from T3 to T7, right? From T3 to T7 here, the interest rate changed. It changed to 0.13. The 13% translate to 0.13. But it was no longer compounding on a monthly basis. It now compounded after every 6 months. That's what they mean when they tell us that it was compounding half yearly. So we divide by 2, right? So from T0 to T3, these are 3 years. From T3 to T7, these are the remaining 4 years. Then the scenario continued. We are told that Mr. Mungayi withdrew 6,032 rands from the account 5 years after making the initial deposit. So between T3 and T5, money was withdrawn. How much was withdrawn? We say minus 6,032 rands. Money was withdrawn. Meaning to say that the 50,000 which started, it did not remain till the end of the 7 years. 6,032 rands was withdrawn, right? All right. Then comes the part whereby they're now saying that after 7 years, we must calculate how much will Mr. Mungayi have in his account, considering the fact that after 5 years, we withdrew 6,032 rands. So this is so simple. This is what I would do. Now I come here and I say that A is equals to P, open bracket 1 plus I over N, close bracket N multiplied by M. So what will I do? I will calculate the interest for the first 3 years. So now I say A here is equal to the 50,000 rands which was initially deposited, open bracket 1 plus the interest rate for the first 3 years was 0.14 over 12. So 0.14 over 12 to the power, remember I must put. So this was the compounding period multiplied by the time, which is 3 years. So 12 times 3, on the previous question we found out it was 36. So we say to the power 36. Then from there, the interest rate after year number 3, the interest rate changed to 0.13 over 2. But this was for the next 4 years, the remainder of the what? The investment period. So now I come here and I open the bracket and I say 1 plus 0.13 over 2 to the power. Now, I must now say that since it was compounding what? On half yearly, so it's 2 multiplied by the number of years, which is 4. So 2 multiplied by 4 is equals to 8. So I say to the power 8 here. So what have I done with these two? Remember, this is a what? This is a compounding the interest part, right? So what I've done is that with these two particular interests, what I've done is that I've calculated the first 3 years, the interest, which is 50,000 rands, and for the first 3 years. And we got that it was 75,000 and something from the previous question. Now we are saying these two, 75,000 multiplied with the remaining 4 years here. Then we get the amount for the full 7 years that 50,000 rands would have earned. But remember, we're told now that in year number 5 here, Mr. Mungayi withdrew 6,032 rands, which means that from year number 5 to year number 7 here, Mr. Mungayi withdrew 6,032 rands. But that's not only the money that he is not going to get. Also the interest for these 2 years, Mr. Mungayi won't get. Right? So now what we are going to do, we are now going to say minus, we're going to subtract the 6,032. But we don't subtract 6,032 alone. Remember, there's an interest rate. And the remaining 2 years, which interest rate was in effect? It was the 0.13 over 2. So what we then proceed to do now, we proceed to do what? we now proceed to say that open bracket, right, 1 plus 0.13 over 2, close bracket. Now, the remaining 2 years was compounding twice, and we have got 2 years. So we set the compounding period of 2 per annum multiplied by the 2 remaining years, which is 2 times 2, which gives us 4 to the power 4, like that, right? So the 6,032 rands which you withdraw plus the interest that you would have earned, now that's what we are going to be subtracting. So the full investment and interest for 7 years minus the 6,032 and the interest that you would have earned for the 2 years. Then we will know how much will Mr. Mungai have, right? So when we go to the calculator, this is what we now do. We now place everything which is here into the calculator, and then we will find out that how much did Mr. Mungai receive after 7 years, having withdrawn 6,032 rands at the end of 5 years. So now we say 50,000, open bracket, 1 plus 0.14 over 12, and then we close the bracket. We say to the power 36. Then from there, we now multiply with what? The interest for the remaining 4 years, 1 plus 0.13 divided by 2, close bracket, to the power 8. So we say to the power 8. Then now we bring it down, and then we say minus the 6,032 rands, right? And the interest that Mr. Mungai lost for the remaining 2 years because he had withdrawn money. For whatever reason that he withdrew money, you know, life can be tough at times. So you can be forced to do what you initially didn't plan. So to the power 4, which is now equal to, then we get 117,876 rands and 22 cents. I have added 1 here because the third decimal number 7 is bigger than 4. So we add 1 here. So Mr. Mungai received approximately 117,876 rands and 22 cents. There we go. That is how much Mr. Mungai received. But that is method number 1. Remember, I promised you 2 methods at the beginning of the video. So let's go to method number 2. Method number 2 is very easy. We are still going to utilize our timeline. Now, what are we going to do? We are going to say Mr. Mungai 50,000 rands. The first compounding period he was given what? An interest rate of 14%, which compounded on a monthly basis, and we found that it was 36, right? So these are the first 3 years, from here to there, done. Now, what are we going to calculate? We are now going to calculate, remember at year number 3, the interest rate changes to 0.13, right? So what we are now going to calculate, we are now going to calculate 1 plus 0.13 over 2. We are going to calculate how much did Mr. Mungai earn in interest for the next 2 years before he made a withdrawal of 6,032 rands. So it becomes 1 plus 0.13 over 2. Now, because we are considering these 2 years and the compounding period is 2, we now say 2 multiplied by 2, which gives us 4. So we say to the power 4, right? Now, once we have done that, the next thing that we now do, we are now going to subtract what? We are going to subtract the 6,032 minus 6,032 rands, right? Now, so let's go to the calculator. We now say that 50,000 rands, open bracket, 1 plus 0.14 over 12, close bracket, to the power what? 36, multiplied by what? Open bracket, 1 plus 0.13 over 2, close bracket, to the power 4. Now, then we now bring down and we say minus the 6,032. which will give us what? 91,627. We are not going to round off anything. So now we have got, we say A is equals to 91,627.90564. Now here, this is 5 years that we have here. Now we have got the remaining 2 years. We have subtracted the 6,032, but there is no interest this time around that we are removing. We have removed it as is. I have calculated the first 3 years and the next 2 years before this withdrawal was made, and then Mr. Mungai withdrew his 6,032 and he remained with the 91,627.90564. Now I'm going to calculate the remaining interest which Mr. Mungai earned for the remaining 2 years. So now I come and I say 1 plus 0.13 over 2, and since it's the remaining 2 years and we know that it's compounding twice per year, it means to the power 4. It's the same with that 2 times 2 which we did earlier on. So I still have this 91,627 on my calculator. So now I say answer, open bracket, 1 plus what? 0.13 divided by 2, close bracket, to the power what? To the power 4, which is equal to, and as you can see, like we found previously, 117,876 rands, and we round off to 20, it gives us 22 cents. So we now say, therefore, our A is approximately 117,876 rands and 22 cents, right? Okay, so if everybody has enjoyed this video, please do consider subscribing, comment, make some suggestions for the past exam papers that you might have tried and maybe you're stuck somewhere, and then make suggestions in the comment section and I can do videos based on the papers that you'd have requested. Share with your classmates, with your loved ones, and please like the video. Till we meet on the next video, cheers.